Okay, this particular lesson we're going to be focusing on combining transformations, part 2, from Unit 2, Chapter 1 on function transformations. And the main focus of this session, or this lesson, is sketching the graphs of transform functions by applying transformations, reflections, and stretches. Let's begin with example number 1. Given the graph of y equals the f of x, construct the graph of the transform function y equals the f of x plus 2 subtract 3. State the domain and range as well of the transform function. Let's do that. First of all, we want to get the mapping rule for the function. Now this function is written in functional form. Some students will be used to writing the mapping rule in this form. Others want to see it in transformational form. So I'm going to rewrite it as y plus 3 equals the f of x plus 2. This is the equation in what we call transformational form. Regardless which form you're looking at, we simply need to write the mapping rule for this function. The mapping rule becomes xy maps to x subtract 2 and y subtract 3. X subtract 2, y subtract 3. It didn't ask for the transformations, but we should be able to list them. We should realize here that we have a horizontal translation of -2, and we've got a vertical translation of -3. I think the way I'm going to approach this one is by simply using my mapping rule here that I just created. We're going to take each point that you see on the graph here, and we're going to take these points, A, B, C, D, and E, and we're going to plug into that mapping rule, and we're going to find the coordinates of the new points, A prime, B prime, C prime, D prime, and E prime, plot the points and join them up. So let's do that. The point A has coordinates 6 and 2. Let's plug that into the mapping rule. Let's see what we get. We'll get 4 and -1. That will be the coordinates of A prime. 4 and -1. Let's take the point B, which has coordinates 2 and 2. Plug into our mapping rule. 2 subtract 2 is 0. 2 subtract 3 is a -1. That would be the coordinates of B prime. 0 and -1. Let's take the point C, which has coordinates x is 1, y is 0. Plug that into our mapping rule. We'll get -1 and -3 for C prime. X is -1, y is -3. There's C prime. So maybe I should state these as A prime, B prime, C prime. Okay, quickly let's do D. Coordinates of the point D is -2 and 3. Plug that into your mapping rule. -2 subtract 2 is a -4. And 3 subtract 3 is 0. That will be the coordinates of D prime, -4 and 0. -4 and 0. And finally, the coordinates of the point E. Right now it's at -4 and -2. Plug it into your mapping rule. -4 and -2. -4 subtract 2 is a -6. -2 subtract 3 is a -5. There's E prime. -6, -5. D prime, E prime, all we need to do is simply join them up, and we got the graph of our translated function. A prime, B prime, B prime to C prime, C prime to D prime, and finally D prime joined to E prime, and there's the graph of our translated function. Very simply. So look at another example. Given the graph, let's sketch this function. Well, here's the graph of the f of x, and here's our new function. Again, we definitely want to create a mapping rule for this function. So what I will do is I will rewrite the function in functional form, again because some students prefer to see it in that form. In functional form, we y subtract 2 equals -1/2 f of 1/2 x plus 1. We bring the 2 over, and we get negative 1/2 f of 1/2 x plus 1 plus 2. Just double checking my calculations here to make sure I'm good. Everything looks good there. Now, again, we need to create a mapping rule based on this equation. XY maps 2. Depending on the equation you're looking at here, I won't point to any particular equation because some of you will look at one, others will look at the other one. The equation will be, the x part of the mapping rule is going to be 2x subtract 1, and it's going to be negative 1/2 y plus 2. I said I wasn't going to point at a particular one, but this is the one that I use, the one in transformational form. I just take the opposite and reciprocal of everything we see. The 1/2 x plus 1 becomes 2x minus 1. The reciprocal of 1/2 is a 2. X plus 1 becomes x minus 1. The negative here does go in the mapping rule. The reciprocal of the 2 is a 1/2. The y subtract 2 becomes a y plus 2. And again, some of you I'm sure are getting that from here. That's okay as well. Now we're going to plug in the points A, B, C, and D again. And we're going to get new points on our new graph. The coordinates of A is 0 and 8. Let's plug 0, 8 into our mapping rule. Plug in x is 0, I get negative 1. Plug in y is 8. I got negative 1/2 times 8 is a negative 4. Negative 4 plus 2 is a negative 2. So there's A prime. Negative 1 and negative 2. Let's plug in the coordinates of B. B has coordinates 1 and 8. So we plug in 1. I'll have 2 subtract 1, which is 1. And of course, we'll still get the coordinate. The y coordinate will be the same as it is for A, because we plugged in 8 in A, so the same result will occur of negative 2 for my y coordinate. So we end up with a point at 1 and negative 2. 1 and negative 2. There's B prime. Let's continue with C and D. Coordinates of C is 1, 2, 3, and 4. 3 and 4, let's plug that in. 3 times 2 is 6, subtract 1 is 5. 4, plug in from y, that's going to give me negative 2 plus 2, which is 0. 5 and 0 will be the coordinates of C prime. And finally, the coordinates of D is 5 and 8. If I plug in 5, I'm going to get 9. If I plug in y is 8, I've already done that, of course, and I get negative 2. So 9 and negative 2. There's D prime. Let's join up A prime, B prime, C prime, and D prime, and let's see what it looks like. And that will be our graph. A prime joined to B prime, joined to C prime, joined to D prime. There's the graph of the new function. Again, notice the way we did that is we created a mapping rule, and we simply take the points that are located on our original function, y equals df of x, plug into the mapping rule, we get a new set of points, A prime, B prime, C prime, and D prime. I think we have one more example to do with that. Same scenario. The graph of f of x equals x squared is transformed to the graph of the g of x equals 1/2 negative x plus 4 squared subtract 7. Again, we need to take this equation and we need to rewrite it because of the brackets here. I got to have a negative 1 outside of x subtract 4 squared subtract 7. And note again, folks, that the squared here has nothing to do with the transformations. It's the base function x squared that has been transformed. Now, some of you can get the mapping rule from that form. Others will want to see it in transformational form. So I bring the 7 over and I get the g of x plus 7 equals 1/2 outside of negative 1 x subtract 4 squared. Multiply both sides by 2 to get 2 times the g of x plus 7 equals a negative 1 times x subtract 4 squared. Now we're going to create our mapping rule, depending on, again, the equation you look at. But your mapping rule should be this: negative x plus 4, comma, 1/2 y subtract 7. 1/2 y subtract 7. I'm sure that some students are looking at this equation to get that, or this equation I should say. Some more of you are probably looking at this equation to get the mapping rule. It depends on what way you were taught. Once we have the mapping rule, of course, we're looking for the transform function. Now, notice there are no points given for the original function. That's because you should know how to sketch the graph of the original function. The original function is simply the parabola y equals x squared. So if you need to create a table of values, then we should be able to do that. So let's create a table of values for the f of x equals x squared. You should know that the table of values will look like this. Let's go -3, -2, -1, 0, 1, 2, 3. I don't know if we need all of those points, but I'll just state them here. -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared, of course, is 0, 1, 4, and 9. So a table of values now for the new function. All we need to do, of course, is take these points, plug into your mapping rule, and we'll create a new table of values. I will do just the middle 5 points. That's enough. I created 7 points here, but I only need these 5. That's enough to sketch the graph of the translated function. So let's take -2, 4, and let's plug it in. -2, 4. If I plug in -2, 4, I will get, it's a negative x, so that's +2 plus 4 is 6. And we plug in y is 4, half of 4 is 2, subtract 7 is a -5. So I got 6, -5. 6 and -5 is a point on my graph. Let's choose the point -1, 1. And let's see where that maps to. -1, 1 is going to give me a 5, because a negative of a -1 is 1 plus 4 is 5. Plug in 1, I'll have a half subtract 7. Half subtract 7 is -6.5. So 5 and -6.5. 5 and -6.5. Right there. Let's plug in 0, 0. See where that maps to. Plug in 0, 0, I get 4 and -7. 4 and -7. Right there. And let's plug in a couple of other points like 1 and 1. If I plug in 1 and 1, I'll get 3 and -6.5 again. 3 and -6.5 is right here. And finally, let's plug in the point 2, 4. So notice again, I've plugged in these points right here, okay, to create a new set of points. Plug in the point 2, 4, and I will get 2 and -5. 2 and -5. There we go. So we can see what our parabola looks like. Parabola is going to look something like this here. And there's a sketch of my new translated function, g of x. Okay, to end the session, or to end this particular lesson, let's look at the key ideas again. To produce the graph of a transform function, y equals g of x, we simply write the mapping rule for the transform function, and we create a table of values for the base function, or we use the points that are given on y equals the f of x, and we plug it into the mapping rule to create a new set of points on the graph of the g of x, and we simply plot the points, and we end up with the graph of y equals to g of x. That ends this particular lesson.